Hello, in September of last year I went to Goldsmith's electronic music studio to try out the EMS VCS4. It is a synthesizer that basically comprises of two EMS VCS3s as well as a keyboard and a bunch of extra things. It's very hard to sum up in just an overview. It's much more than just two EMS synthes plonked together, but it's also a piece of history because it's one of the only surviving pieces from the EMS Putney synth labs, which where most of the equipment got stored in a basement that ended up getting flooded, this one was not. Anyway, there is a link below to the video covering my time with the EMS VCS4, and that is below. Whilst I was there, understandably, I somewhat fell in love with this machine, and it made me realise that I would really like an EMS VCS3. However, if you are in the know, the prices for an EMS VCS3, well, they're a little bit silly. The original ones are pretty mental, and EMS still actually make them. However, the waiting list is nearly 5 years long. But what if I told you there is another way? So yeah, the last day of my visit to Goldsmiths, I decided to email the Cloney company. This is a German company that make one-to-one replicas of the EMS Synthi. From what I've heard, they're pretty much exactly the same as the originals, if not better, because they've got slightly better components like potentiometers and pin matrices. Well, I sent an email over to Matt Simp's part, and after a couple of days of back and forth, I ended up buying one of the Cloney kits. So let's have a look in the box. What is inside of a Cloney box from Matt Synth Parts? Let's find out, shall we? Oh ho ho! This is cool. Oh yes. Packaging, lots of good packaging. First off, I think this might be the instructions. Let's have a quick peek, shall we? Ooh. Oh yeah, this is it. Complete instructions, construction manual and accessories kit, assembly instructions, and the electronics kit. Population guide, so that's for the circuit boards, and then the calibration guide, all nice and chunky, plenty of stuff to be reading, and we'll be reading it in the video. And we've got a package list which has got everything checked on the 30th of October 2024. So it looks like it's well labelled. This is the panel wires, cool. We've got a bunch of different potentiometers. Those feel like they're proper potentiometers as well. Oh yes, here we go. This is the meat of it. This is the free circuit board. So on the back of an EMS Synthi, you may or may not know, there are 3 separate circuit boards. That is basically the whole of the synth. And as you know, this is a Cloney, so it's built in the same manner. And these have already been populated. This is something that Matt offered to do. But if you bought the kit, it would come with these unassembled unless you pay for them to be assembled. But apparently Matt already had some assembled ones, so he was kind enough to include these in here as part of the perks of making a video on the process of making the kit, which is amazing. So thank you very much, Matt. It's saved me a couple of days, a few days of soldering actually, I think this would be. And these are the 3 circuit boards, very close to the original design. Carrying on, we've got the spring tank, because the Synthi of course has a spring reverb in it. We got a selection of sundries. Looks like hardware. We've got jack sockets, switches, Jones plugs. This looks like the circuit board where the other circuit boards sit into. That sits on the back. Oh, what do we got? Amazing. We have the joystick, and that is a proper joystick. That looks really nice. We had the knobs. After speaking to Matt, the kit actually comes with the multicoloured Mark II ones, but I wanted to go for the Mark I ones for a reason we'll talk about in another video. Might not make sense right now, but it will. It should do. In this box, we have the transformer, 18 volts. Oh, we've got some speakers. Oh yes, we've got the multi-turn potentiometers. These are for the oscillators. There's 3 of them, of course, because there's 3 oscillators. But on the front of it, it's basically like a gearbox. And then that connects to a proper potentiometer on the back. We'll have a closer look at that in a little bit, but they look really nice. Oh, yes, of course. We've got the VMU. This looks to be all the screws, hardware, heat shrink, etc. We've got a bunch of metal hardware. As you know, this is going to be a like-for-like Cloney, so I'm really hoping there's some wood in here as well. I think I know what this is. This is going to be awesome to have a look at. Oh, it is. How cool is that? This is the patch bay. Wow, that is serious. What? Oh, it's not even plastic. This is machined aluminium. That is amazing. It is a proper patch bay built by Gridlinks in Germany. Oh my gosh, got patch pins as well. That looks proper. Okay, so here's the big stuff. What do we got in here? Okay, first off we have what looks to be all the wood bits. So this, of course, is the wood. This is proper wood as well. I don't know what that bit is, but it'll all make sense. Oh, that's the side panel. Oh, wow. We got the base of the side panel. So that's going to sit like the here. I'm assuming there's some dowels here as well. There's the dowels and all the bits to put it together. And another bit of wood that we'll find out what it is in a bit. And of course, what looks to be the back or the bottom panel. Ooh. Keeping on, I'm assuming now this is all the metalwork. So we've got this chunky piece of aluminium. This looks, because it's got holes here, 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 and here, that looks to be the base plate. So that's the bit that goes on the bottom of it. So we've got right here, this looks to be, oh, nice. This is the back panel, serial number 121. Keeping on, now we find, oh yeah, that's amazing. This is the panel. Yeah, that looks good. That's where the VU meter goes. That looks really nice. Oh, how cool is that? That's blooming amazing. And the other panel, this is obviously where the pin matrix goes, joystick, all of the knobblies. Manufactured by an honest venerator, the Cloney Project. Oh, that's proper, that's solid as well, and looks really nice and durable. I cannot wait to build this now. So yeah, that appears to be everything. So I guess we should start building.
And start building we shall. We're going to begin, because the circuit boards are already soldered. I would have done that first with the cabinet. So we're going to use the cabinet manual and put them together. We're going to get these dowels. We're going to put this all in together. I'm dry running it first because I didn't know what to expect, how well it was fitting, and that's what it suggested to do in the manual. So I put it all together and then put the panels into the wood to make sure it all sat together squarely, just to see how it all went together. And when I was happy with that, I got out the glue and started stonking it together. Bits are squidging in here, bits are squidging in there, and before you know it, it's all coming together and sticking together like a nice big gluey mush. Yeah, so I made sure to put everything in it, including this, which is the base panel, that's the feet in there, into the bottom of it, so it all went in squarely. I did all of the pilot holes and everything I was supposed to do before all the glue dried, so everything that was supposed to fit onto the box fit. There's an extra bit of wood that connects there, and there's also the back panel. And whilst that's drying, we're going to get acquainted with the accessories manual. This will show us all of the bits that we need to put into the panels. So there's a whole bunch of different bags of potentiometers, all labeled if you've get the kit, and yeah, we're going to be putting it together bit by bit. All of the there's only about 4 or 5 different values of potentiometers. There's linear potentiometers, exponential potentiometers, but it's all described in the manual. So this is a video of me putting it together onto the top panel. 27 in total, and then another 3 on vernier dials, and then another 7 on the base. Just keep in the back of your mind that you're going to have to solder wires onto all of those right at the end. So yeah, it's going to be great. Anyway, we're going to be putting the multi-turn verniers on. These are the kind of gearboxes that sit on the front of other potentiometers. So we need to put the other potentiometers onto this mount on the back that then connect to the back of the vernier dials. So we line it up nicely. It took a little bit of wiggling with this. You need to keep it loose and kind of see where they kind of sit just right, and when they're just right, you get the screws and you tighten them up, and boom. As you can see, it's a 10 turn for every potentiometer turn for that extra fine tuning. Oh yeah, baby. Now we put all of the things in, like switches that also have these very rather fetching red rubber tops, and then we've got the other bits like the VU meter, which has 4 screws on the back. And then we do the bottom. I shouldn't have done this out of the case because I didn't realize I wouldn't have been able to get both panels in, but it doesn't matter. A couple of final pilot holes for the power supply, and then we're going to glue the bottom and the top together. Finally, commit, and then nice bit of oil, and it looks lovely. This case went together really easily. Now we put the panels in. As you can see, the bottom panel doesn't have any in there now because, yes, I needed to take it all out to get it in. These speakers took 3 months to put in, believe it or not.
Okay, I must admit, I actually shot that in January. I actually started building this kit back in January, just before I started the big bogey, but for unexplainable reasons, I have no idea why, my brain just flipped and I was like, I'm going to restore a classic car. I don't know what happened there. We're going to be finishing that very soon. The engine is nearly done.
But before we end up at the present day, let's have a look at where I've got to with the kit.
The next step is putting together the power supply assembly. First, start with the rectifier, plonk that in, and the transformer that takes the mains voltage and brings it down to AC 18 volts. And then we've got these capacitors in there as well, and it's basically like Lego or Meccano. All you need to do is follow where bits go and follow the instructions and solder it bit by bit, but it helps to understand what is actually happening. These two are the AC outputs of the transformer. They go through these fuses and then into the rectifier, which rectifies it to DC voltage and then filtered by these capacitors, if you understand any of that. Anyway, we pop it into the enclosure and connect up the pilot light. You'll see I put a resistor in there. Turns out that was the wrong resistor, but I'll find that problem out later. Anyway, now we're going to put all of the things back into the bottom panel and admire its beauty because it looks lovely.
So that brings us up to this point, and you can already tell it looks incredible. The finish on the panels are amazing. It is nothing short of a masterpiece, and I've managed not to scratch any of it yet, which is great. So yeah, the next thing we need to do is carry it on, because if you can notice the back of it, well, it's completely empty. There's no wires anywhere. We haven't got the bus board. In fact, I have just finished the bus board, so the first thing I need to do is plonk the bus board onto here and give it a bit of a soldering. So let's go.
The first thing we do is we'll wire the positive voltage wire, the negative voltage wire, and the ground wire to the bus board. And that connects under the bottom of it. You screw the bus board in and then realize you've forgotten something and unscrew it again and then figure out where to put the spring reverb tank. So I measure the holes from the top, pop in some holes through these wooden bars and then connect it to the bottom. So the spring reverb sits on the bottom and the bus board sits on the top of these bars. Now we get the free circuit boards and pop them into the bus board just to see if they all fit and then work out exactly where the top mount goes. This is the piece of metal that holds the top of the circuit boards in, but I realized I should have done that after because I can't wire the potentiometers. So we're talking about that, we should start wiring it. So this wiring diagram shows you all the common wiring. So the red wire is the positive voltage, positive 12 volts, the blue is negative 9 volts, and the black wire is the ground. So I'm going to start by connecting all of the black wires together. This is a big bus and there's no real way of doing it. You can follow the diagram in the kit, but I just kind of made it up as I was going. So all of these connect together and then they go down and connect to the bus board, which then connects the whole thing to ground. Always double check your work, and when you're happy with it, go to the next wires, which happens to be the blue negative voltage, and then do the red wires, which I had none of, so I used orange wires. The kit does come with multi-core cable, but I like using single core, and if it works for telecom and Strouder equipment that receives loads of vibrations, then it's good enough for a synth. And after we've added a couple of panel mount components, we're going to connect the connectors now. So this is connector 24, so we're going to get the Molex connector, pop it in, and then use the crimper and the metal crimp, and then crimp a wire and plonk it into the connector that corresponds to the one in the diagram, which is this one right here, 24/1. There's a bunch of these, so we just need to run through and do the same, rinsing and repeating, and then repeating and rinsing, and then keeping on rinsing until you can't rinse no more, and then you repeat until you start rinsing again, and then when you're finished rinsing, hopefully that's all done, because you should be finished by that. Lovely job.
Whoopsie daisy, I've made a bit of a boo-boo. You see, on the back of this, I've done all the wiring with a single core cable. That means the cable's just got one core and it's going from the source to the destination or whatever. I'm a bit of an idiot, it's my fault, I overlooked it. See, on the bottom right here, it actually says cable types, unshielded, shielded, underlined, and a load of these actually have lines underneath them. So some of these are actually supposed to be shielded cables going from here onto the sockets, because the sockets that are meant to be shielded, the holes next to where they go, there's actually a ground point. So the shielding of the cable goes to the ground next to it. I'm assuming these are actually the audio paths and stuff. Well, yes, I probably should replace them. However, this is where I'm gonna do a bit of a spoiler for the next video. Here we go. You see, I've got a gig coming up at the end of this week, and I haven't built just one of these. You know, I really got into the VCS4 well. I've managed to get hold of 2 kits with the aim of building ultimately a VCS4 clone, you know. This one I haven't got to wiring it yet, but now I know the mistakes I've made with this. I'm going to build this one with the shielded. And I'm going to compare them because, I don't know, do you reckon it makes that much of a difference? This is relatively similar to a lot of the other DIY synthesizers that you've seen on this channel. Most of those have internal panel wiring, but none of them have shielded cables. So let's find out. And if it does make a horrendously massive difference, I'll just have to rewire this. It's not the end of the world. Anyway, we'll talk about this other one later on. Let's carry on with this.
These little purple checkered squares correspond to the wiring that connects to the pin matrix. So we're going to connect these up. These are all shielded, so it's better to start now than never. So I connected all of these together. Most of them connect to the back of potentiometers or the bus board, and there are 16 ins and 16 outs. Now for the back panel connections, including the bus for the grounds, and then the 3 mains cables and the rest of the wires that connect to the jacks. When you're happy with that, plonk it in. And now it's time to wire the mains cables to the transformer. Lovely.
I'm pretty confident we're at a point that we can plug it in. We're going to be doing the smoke test, the buzz test, and the voltage test. So the circuit boards aren't in there in case there's a problem and the circuit boards go up in smoke, which we don't want. Okay, no sign of life. So I've managed to blow both of the internal fuses. So something's wrong.
What an idiot. I wired the rectifier in back to front. That means it wouldn't take the AC and convert it to DC via these 4 diodes inside there. After moving it around, luckily it still works, a rugged little beast. It turned on nicely. Now we're going to test the voltages. So we've got to test the inputs. They're about 25 plus and minus volts. And yeah, that sort of matches up ish. It's a little high, but that's the way it is. Now we're going to put the first board in, which actually has the voltage regulators for the synth circuits. So amazingly enough, these 2 little regulators connect up to the uses the top panel as a heatsink. Really smart. Anyway, that now gives us a nice plus 12 volts that we need to fine tune using this preset potentiometer till we get bang on 12 volts. And then we do exactly the same for the minus voltages, which is actually minus 9 volts. And we have to adjust that after we've got to the plus 12 volts right there. There's the minus 9. Now we know we've got those. We get the second board in, test the voltages again, make sure nothing's going up in smoke, and then finally put a third one in. Fabulous.
It's time to give it a go. Oh ho ho. It's getting messy around here. Let's see. Whoa. There's one. Oh yes. Oh, no noise. Okay, well, it's got some life.
Now for the best bit of the process, the bit you look forward to. Whether you're building your own self-designed synthesizer or a kit, there is nothing quite like the ending where you put all of the knobs on. It's just, oh, it's the icing on the cake.
So now it's all put together. I did the calibration using the oscilloscope. You could do that if you really feel. Do the calibration if you're planning to plug it into other bits and bobs. Or, you know, I mean, just don't be scared by the whole calibration malarkey. It's not that important. Right, we're going to have a look at what it does. So if you haven't already seen the VCS4 video that I did on the VCS4 at Goldsmiths, which is basically 2 of these modified plonked together, then have a look. I go through a lot of functions of the VCS3 in that video, but we're still going to go through the basics. On this side is outputs, on this side is inputs. We're going to get the output of oscillator 1, plug it into the output channel, and then you get that. Turn it up a bit. Oh. And then get it to the point of saturation. So you can do that if you want. What about the ramp wave output? So saturation and back, bring it down. The output of oscillator 2, square wave. Oh, turn it up. And then obviously plug both in like this. Turn it to the triangle wave for a softer tone. Oh, there we go. And whilst we're here, we may as well plug in the output of oscillator 3. now we're going to plug the output of one of the oscillators. Let's go for the ramp wave of oscillator 1 and into the filter, and then get the output of the filter. Now we may as well get the joystick plugged in. So the output of the joystick up and down into the input of the oscillator 1 frequency, so we can get a bit more range from this. But we can also plug in another oscillator that will mix in with the first oscillator into the filter. So we'll plug the square wave of oscillator 2 in as well. Turn it up. Plug the left and right of the joystick into the second oscillator control, why not? Whilst we're here, let's plug in the noise input into the filter as well. Now we're going to plug the output of oscillator 3. We're going to have it in a really low oscillation. Oscillator 3 is different to the other two oscillators. These are primarily designed for the musical ones, and then this one is a multi-purpose. It could go anywhere from the very low frequency. For instance, if you listen, we've got a very low frequency. We got up to 0.5 hertz. You use a calibrator to get this bang on, and then you go down to 500 hertz. So now it's wiggling around. You can hardly see because it's set on. Here we go. So now we're going to plug the output of oscillator 3 into the input of the control voltage of the filter. So now it's going to wiggle it. It's going to. But this all doesn't sound very synthy until you unplug the output of the filter, but then get the output of the filter going into the input of the spring reverb, and then the output of the spring reverb into the output. That sounds more like... Now we've got the wetness control. We can also get the wetness control. Actually, let's get the wetness controlled by the LFO, the oscillator 3. So the dry and wet mix of the reverberation now. It's because this means the reverberation becomes gated, but then we unplug it. Each of the outputs actually has a filter on it, which is pretty snazzy. And you can also use the LFO or any of the voltages to adjust the output level as well. So we can go... So this is after everything. Okay. Right, so what we're going to do now is, instead of having the oscillators 1 and 2 mixing together into the filter, we're actually going to unplug them and put them through the ring modulator. So ring modulator input A goes the output of the oscillator 1, and then ring modulator input B to the output of oscillator 2. So now, in theory, if we get the output of the ring modulator plugged into the input of the filter, now get the output of the LFO into the input. We're instead going to plug that into the envelope shaper, and then the output of the envelope shaper we're going to plug into the reverb instead. We've also got a voltage controlled over the decay. So with the decay we can plug that into the LFO as well, so we can adjust how the envelope shaper time works. So let's do that in real time. Let's get it going into oh, there we go. See what happens when we get the envelope voltage output into the input of the oscillator. I don't know what that'll do. And then also now I'm just plugging everything into everything. So now I'm going to get the oscillator 3 also controlled with the joystick. And the input of the VCA also. I'm just messing with things now, I'm just plugging things into things. Alright, started well. filter. Ho ho ho. You can make a lot of funky noises with this, and in order to make it musical like I did in the VCS4 video, it's really good to use the joystick. But obviously there are other ways. In the next bit we're going to be plugging it into a sequencer, making it do a bit of a sequence. This right here is the sequencer that's playing that pew, 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 pew. So I've actually got it wired into the quantizer here. So it's actually sending out volt per octave calibrated notes. That's why it sounds so right, because it's all in tune. And all you have to do is get the outputs of these, wire them into the control voltage inputs, and in order to get them in tune, you've got to scale them with the input levels. So it's like plugging in a microphone, but instead of a microphone, it's voltage, and then you just kind of tune it until the octaves match up, and then it actually matches up really well. The scale of voltage per octave going into that works. So people saying that they're not very musical, well, obviously you can do it, it's just a little bit of a faff. Got an oscillator going. Quite low, and then we've got another oscillator doing the other. That's set up, and the noise can come in as well. And we've got the joysticks wired in. So these switches are really handy. They're just simple switches that switch between 1 and 2 voltages, which means you can make 2 separate sections, if you will, which is what we're going to do here. So we got that done, and now let's go flick it to a different. Now it's just. So it's going over to this one. Just one of the oscillators, so I think it's the top row. I haven't actually got a clock going into this. And this goes before the quantizer, so both of these go into the A and B of this switch. I love these things. Well, I actually built these in a little bit of a rush because I had a plan of building them to play them in a show at Canterbury on Saturday. And funnily enough, the day before, I started a building live stream about lunchtime, and I didn't finish that live stream until 6 AM in the morning, soldering. That was over on Patreon. You can still watch it. You can watch it back. You can see me just despairing and then disappearing for half an hour every so often, having a quick nap and then getting back on it. It was for International Drone Day with Coastal Electronauts, and funnily enough, a couple of the bits started breaking in the middle of the show. So I actually finished making these the morning of the show. I'd soldered just constantly because I realised I wasn't going to get them done in time for the show. And they still weren't 100% done. For instance, this one actually is only half working at the minute. I need to spend a bit more time in it in the next video. We've got one oscillator that isn't working and the envelope shaper isn't working. I'm going to go and have to diagnose what the problem is. I'm pretty sure it's board level and I might have blown it with some funky things. I'm not sure. In the show on the other one, the filter stopped working. That was down to one of my solder joints. But apart from that, it worked really well. So I need to give it a good old going through until I play another show with them, that's for sure. If you've put the pieces together, you'll probably realise that I'm going to try and make a VCS4 clone. So that is these on top of the bass station and the keyboard. I really enjoy it as an instrument and that's why I wanted to get a like for like version. You can make these circuits by yourself on stripboard and things like that. It has been done and I think I've done the envelope shaper actually in a module on Cosmo 2.0. But to get the actual look, the proper look and the proper feel, which I feel is half of the thing with the Synthy, then, you know, this is the way that made sense for me. If you squint your eyes, it's an EMS. I mean, even if you don't squint your eyes, it's basically the same. It's exactly the same shape. It's exactly the same size. Apparently you're supposed to chamfer the edges to get that 100% look, but I'm not going that far down. The only real telltale sign when you just look at it is the sign that says the Cloney Project on the bottom right there. But yeah, going to be making a base station for it. This is not the last video these are going to be in. I've started collecting the pieces for the base station already. Another thing about doing it with the kits, because I can't afford the proper ones anyway, and even if I could, I don't think I could be able to justify it. The great thing about having the kits is you can modify them. There was loads of things whilst I was building it and playing with them that I wanted to do differently and add switches and jack sockets going into things. So I won't feel guilty about drilling a few holes in this and putting some switches here and there. You know, it's not a piece of history, it's just a very, very good quality clone, which is great. As for the process of building the kit is amazing. It's very well documented. It's very well labeled. However, I do have to say, I did get quite confused with the manuals at times. I felt like I was bouncing between manuals and maybe I could have done with reading them better. It might have been down to me, but I did get a little bit confused with them. But hopefully, if you're going to build one of these, mix it up, watch this video and also read the manuals. I did actually build the second one after I got most of this one done, and I got it together quite a lot quicker than the first time because I knew what I was doing. If you want to see the full 25-minute of the rundown of the setup that I had for the gig, well, that's over on Patreon if you want to have a look at that. And also you can download some sounds and stuff that I've made with this, which you can use as special effects and samples and whatnot. That's available over there as well. If you want to see the next phase of this, including the process of fixing this one because it doesn't fully work, like I said, and also making the base station, I'll be talking about that in detail thoroughly over on Patreon before it ever becomes a video. For instance, I've been talking about building these for the last 4 or 5 months over on Patreon because the car got in the way, didn't it? But yeah, go and head over to the Coastal Electronauts YouTube channel because there is the full show over there and you'll see me panicking as it stops working and things. I spent a lot of time building it and not much time figuring out its nuances. But yeah, anyway, if you like what you see, don't forget to subscribe, and this is the Cloney Project and it's linked below, and don't be scared to try it. Have a lovely time.